So the first question we're gonna do is we have an arithmetic sequence where the first three elements are given as u1, 5u1 minus 8, and 3u1 plus 8. And we are supposed to show that u1 has to equal 4. And we remember that if it's an arithmetic sequence, then the distance between each element has to be constant. We could of course substitute u1 equal 4 into these. We'd get 4, 20 minus 8, that's 12, and 12 plus 8, that's 20, so there's a difference of 8 between them. But that's considered inelegant, so we need to basically solve this for u1. And one way of doing that is to look at the difference, basically. So the difference between the second and the first element is 5u1 minus 8 minus u1, and that has to equal the difference between the third and the second, so it's 3u1 plus 8 minus 5u1 minus 8. And this is a linear equation with just one unknown. Simplifying and solving, I get this turns into 4u1 minus 8 equals 3u1 minus 5u1, that's negative 2u1, and then plus 8 minus negative 8, so that's plus 8 again, so plus 16. Rearranging gives me that 6u1 equals 24, and therefore u1 equals 4, which is what I wanted to show. Another way of doing it would be to show that the second element has to be the midpoint between the first and the third. So if you add u1 and 3u1 plus 8 and you divide that by 2, you should get 5u1 minus 8, and then you can rearrange again and find that u1 equals 4. So those are two valid approaches. So that was the first part of the question. The second part, we asked to prove that the sum of the first n terms in this sequence is a square number. So basically show that u1 plus all the way up to un is some kind of whole integer squared. And I'm going to use then the formula for the sorry, I had it somewhere here. Yeah, I'm going to use the formula from the formula booklet, and because this is of course a known formula, it's Sn, the sum of all the elements up to n, equals, for an arithmetic series, n divided by 2 times times 2u1 plus n minus 1 times the difference d. And here I am allowed, of course, to use the fact that I know u1 and I know d to be 8, which follows from this one. So I'm going to rearrange it. Sn equals n over 2 times 8 plus 8 times n minus 1. So Sn equals n over 2 times, if I expand this, I'll get 8n minus 8, so that'll cancel each other. So we say 8 times n equals then 4 times n squared. Aha! This is of course the same as, so we have Sn equals 2n everything squared. And since 2n has to be an integer, therefore the sum of the n first terms of this sequence has to be a square number.